Now let's solve the part of the questions where we are supposed to find the domain and the range of a given function. So first, let's start with finding the domain of a function. Okay. So we have y equals to f of x, which is equals to x plus 3, 4 minus x squared minus 9. So in order to find the domain of a given function, you have to look at those values of x, which could make the function to be undefined. Okay. And the thing that makes functions undefined is such as division by 0 or a negative number under a square root. Okay, both of these can make the function to be undefined. Okay, so in here, our expression of interest is this term in the denominator here, right? So we have to look at what are those values that could make this 0, or what are the terms, because we have a square root here. So we also have to look at the terms that could make the expression under the square root to be negative. Okay, so let's start from the things that will make 0. Okay, so we equate the denominator equals to 0, and we have 4 minus square root of x squared minus 9 equals to 0. Then if we take the square root to the other side, we have 4 equals to the square root of x squared minus 9. If we square both sides, okay, so we have like 4 squared equals to square root of x squared minus 9 all squared. Now this cancel this, and then we have 16 equals to root x squared, x squared minus 9. If we take 9 to the other side, so we have 16 plus 9, which is 25, is equals to x squared. Now, if we take the square root of both sides, we have x equals to plus or minus the square root of 25, which is equals to 5. Okay, so we have x is equals to plus or minus 5. Now, this is a special point in our domain because this point is not in the domain of our function. Why? Because this is a point which will make this expression to be equals to 0, right? So we cannot have 5 or minus 5 in the domain of this function. All right. Now, the next thing we have to consider is the term under the square root. So we have, let me draw a line here. Okay. So we have x squared minus 9, right? Okay. So we don't want this term to be equals to 0. So we need a condition such that x squared minus 9 should always be greater than or equals to 0. All right. So in this case, we can solve this. X squared should be greater than or equals to 9. And if we take the square root, so we have x should be greater than 3, or x should be less than minus 3. Okay, if you remember how to solve inequality from high school. Okay, so there is no magic here. All right. Okay, so we have our points here. Now, you could go ahead, for example, make an arbitrary number line and put these points that you have. Okay, so we have some point of interest. So if we draw a number line, let's say something like this. Okay, so let's pick like the middle to be 0. Okay, so we have a region Okay, on this side, our number of interest is -5, and we also have -3. And on the other side, we have 3 and we have 5. Okay, so this is positive infinity here, and this is negative infinity here. Okay, so our function is defined, the domain of our function is defined starting from anything between negative infinity up to -5. Okay, but now it's not defined at -5, so we have another region between -5 and -3. Okay, but it's defined at -3, but not in between. Okay, and then we have from 3 again. Sorry, so it's not defined here. So let's write it here from 3 to -3. Okay, 3 included to 5. Okay, and then we have from 5 to infinity. Okay, so this point, this point, this point, and this point, and everything in between. Okay, so all we have to do now is put the union of the two sections. Let's use a different pen here, maybe the red one. Union. Okay, and then this is our domain. Okay, so the domain is the combination of all this region. So it's the combination between negative infinity to -5 union -5 comma -3 included union 3 comma 5 union 5 comma 8. Sorry, infinity. Okay, and this is the domain of the function. Now, the next question is to find the range of 2 plus x squared over x squared plus 4. Okay, so we need to find range for the expression 2 plus x squared over x squared plus 4. Okay, so one of the easiest way to find a range of a function is to graph the function if the function is easy. If the function is not easy to graph, you could try to simplify the algebraic expression, right, to something simpler, something that you can easily see what is happening. Okay, and let's try to take the second approach here. Instead of trying to graph this function, let's try to simplify this expression. So if you look at this term here, this is an improper partial fraction. Okay, so we can simplify this by using long division. For example, if we take this, okay, so this will be x squared, and then this is going to be x squared plus 4. Okay, so x squared into x squared, this will be 1. 1 times x squared, so we have x squared. 1 times 4, then we have plus 4. And if we subtract this, we have -4. So this expression in the bracket, okay, so this is exactly equals to 1 minus 4 over x squared plus 4. Okay, hence our expression can now be written as, instead of 2 plus this, we can write it as 2 plus 1 minus 4 over x squared plus 4. So 2 plus 1, this is equals to 3. So you have 3 minus 4 over x squared plus 4. Okay, so we need to find the range of this. Okay, we need to find range. Okay, so the beautiful thing here is we can actually see what is happening. So if you look at the denominator here, right, this x is squared. So it doesn't matter what your input is, this is always going to be a positive term. Okay, so unless when x is 0, right, this denominator will always be bigger, okay, or greater than the numerator. Okay, and you know that when you have two positive number where the denominator is larger than the numerator, you always have a fraction, right? Something like 1 over 4, 1 over 10, 1 over 1,000. Okay, you have a very, very small number. Okay, so let's take a look at the extreme case. The extreme case, okay, when x is equals to 0, okay, when x equals to 0, we have 3 minus 4 over 4, okay, which is equals to 3 minus 1. Okay, now this is 2, right? So the minimum this function could be is 2. Okay, because which will be at x equals to 0. At anything else, this is going to be something greater than 2 but less than 3, because you are subtracting a very, very small number from 3. Okay, so now this is kind of obvious. Now you can see that the range of this function, okay, therefore the range is, okay, 2 to 3. Okay, so the range of the function is going to be between 2, we have it here, right, and 3. Okay, the reason why it can never be 3, because this will always be some small number. Maybe I should write it. Okay, okay, so this term there is a very small number as x goes increases to the left or to the right, because the x is squared. Okay, and the maximum it can take is 1. When we consider this maximum, then we have okay, when we consider this maximum, we have 3 minus 1, which is equals to 2. Okay, but it could be anything between 2 to 3, depending on how large or how small that number is. Okay, so therefore our range of the function is 2 included and up to 3, where 3 is not included in the range of the function. Okay, so this is the solution for the domain and range, and how you can find the domain and range of a function.